This is Robin. So today we will be discussing the question number 22 from GATE Physics 2020 exam. And as you can see, this question is regarding the solving the complex integration, and you must have learned the various techniques of complex integration and are considering around the integration around the contours. So that's the concept which is mainly used in this problem. Now you are mentioned the contour over which you have to integrate this function, and you have to find the value of this integration by 2 pi I. So whenever you see the form like this, there are two things which should come to your mind. First is residue theorem, and the second is Cauchy's integral formula. Because if you see carefully, this is the form which is related to that. So I will tell you to do the problem, to how to tackle this problem using both of these ways. So that's the idea of this problem. Okay, so right now what you would do is, first let's write the quantity which we are interested in, that is all over the contour C, and your f of z is this 2 by z plus 3 by z square. Okay, now residue, according to residue theorem, your contour, let's draw contours first. It's z equal to 1. So if you see, this is nothing but 2 pi I times sum of residues of the poles. So you can see the z is equal to 0 lies in the contour z equal 1, and that means that's the only pole for this function, because you can see it z, you can write this function here as z q minus 2z and plus 3 by z square. Okay, so the z equal to 0 is a pole of second order. Okay, now the integration of this would be 2 pi I times the residue, and residue of this is simply the coefficient of 1 by z by the Taylor series the Lorentz series expansion. So this is nothing but minus 2. So your total quantity would be 1 by 2 pi into 2 pi I into minus 2. So your answer has to be minus 2. Okay, so this is one of the way, right? Now the point is, what about Cauchy's integral formula? First write that. So you have to take the nth derivative at a pole A, and that is n factorial by 2 pi I, and you have to take the integral over the contour f of z by z minus a power n plus 1 dz. So if you compare with the form given, your f of z is nothing but zq minus 2z plus 3, and your n is nothing but 1, and your a is 0. Okay, so this is nothing but f of 1 at 0 by 1 factorial. Is it clear? Now, so basically you have to take the first derivative of this which is at 0. So 3z square minus 2, and the value at z equal to 0, which is minus 2. So that's clear that if you take this at z equal to 0, so the required quantity would be minus 2 by 1 factorial. So that is just minus 2. And you can see this clearly agrees with the answer from residue theorem. So now you have the idea of how to tackle the problems like this of this form of the contour integration. So you have one way residue theorem, and in that also the way to calculate residue has two ways. One is by Lorentz series expansion, and if you know the coefficient of 1 by z, you can just clearly use that. And there is another way of calculating it using the derivatives, which is equivalent to what we do in the Cauchy integral formula. So the second way is nothing but Cauchy integral formula. Yeah, so the answer is minus 2. Thank you.